All right, this is lesson 6 of unit 2. So up until this point, we've talked about parabolas, and we have individually talked about how A, H, and K all affect our graph. So this note here is going to be kind of all-encompassing. We're going to put all of that information together because, unfortunately, we will not be seeing these equations as separate necessarily. More so, all 3 of these transformations will be applied to the same parabola. So we'll need to know how to put all of those together. So this is kind of a nice summary of the last three notes. Yes, 3 notes. Okay, so far we've looked at the properties for quadratic relations. We've looked at x squared on its own, our base graph. We've looked at ax squared. We've looked at x squared plus k, and we've looked at x minus h squared. We've also discovered what happens to the graph when we change the values of. So when we change the value of a, we see 3 different things. Okay, we can see a stretch, a compression, and or a flip or a reflection. Okay, so that was part of that note that my screen kind of messed up. That was kind of the summary of that. Okay, for K, we saw vertical shifts, and for H, so vertical shift up and down, right? And for H, we saw horizontal shift. So that was to the left or to the right. Horizontal shift. Okay, so now, like I said, we can put all of this together. So we're going to be considering the quadratic relation y equals a x minus h squared plus k. So all we're doing here is we're putting all 4 of these together into one because, like I said, that is how they are going to appear. Okay, so effects of changes in A, H, and K. Using properties from the other quadratic relations we've studied, fill in the blanks below. For any quadratic relation in this form, relative to the graph y equals x squared. And all that means, the relative to the graph y equals x squared, is the transformations applied to that base function. Okay, so how changes in A affect the graph? So like I said, this is a great summary note for you. So make sure you're filling it in. So the value of A determines the orientation, which just means, in this context, if it's opening up or down. Okay, so it determines if it's opening up or down, and it determines the shape. So by that I mean it determines if it's wide or skinny, right? Those 2 options. So if A is positive, our parabola is going to open up. If A is negative, then the parabola is going to open down. Okay, if it's opening down, that means it's flipped, right? That's all that means. If A is greater than 1, the graph is going to be vertically stretched. Okay, which means it's going to appear to be skinny. Again, think about pulling those 2 ends up or down. You're stretching it out. Okay, if A, okay, and what this means here is if A is if A is greater than 1 and less than 1. So what that means, you might want to make just a note, and I don't have a whole lot of room, but I will just kind of turn my things sideways. So what that means is fraction or a decimal. Okay, that's what this one means here. So if A is a fraction or a decimal, the graph is going to be vertically compressed. Okay, when it's vertically compressed, again, think of yourself standing in the middle of it and pushing the sides out. so that it appears to be wider. There should be an I there. Okay, so that's A, right? So A can do multiple things. It's going to either compress or stretch it, and it also can make it flip upside down. For K, if K is positive, then our vertex is going to shift up. If K is negative, our vertex is going to shift down. So that one's pretty simple. Okay? Now looking at H. So if H is positive, then we're shifting left. And if H is negative, we're shifting right. Okay. So vertex coordinates. Coordinates of the vertex can be easily found by looking at the equation of the relation. Okay, so this part is new. Up until this point, everything there has been a summary, but this is a little bit of new stuff for you. So if we are given the relation y equals x squared plus k, our vertex is always going to be at 0, k. Okay, that means our x-coordinate is going to be our 0, and our y-coordinate is going to be whatever the k value is. So if we look at these examples, the vertex here would be 0, 3. And the reason it's 0, 3 is because my k value is 3. Okay, this one here, my k value is negative 11. So my vertex is at 0, negative 11. Okay, if I have x minus h squared, my vertex is going to be at h, 0. Okay, so when we are looking at h, this is a bit trickier because it's going to have the opposite sign. So instead of my vertex being at negative 2, 0, it's actually at 2, 0. And I don't want you to get too confused by that. I will quickly explain why that is, but if you can just remember that it's the opposite, that will be fine. Okay? It's because this original equation has a negative sign. So technically, we subbed in positive 2 here. Okay, if we subbed in negative 2, if our h value is actually negative 2, then it would appear as positive 2 because it would be minus negative 2, which is the same as plus 2. But again, if you just want to accept, okay, I just have to remember that it's the opposite sign, that works too, okay? Hopefully that explanation helped a little bit. So for this one, again, this appears as positive 9, right? But again, it's because we have that double negative. So we actually plugged in negative 9. So my vertex would be at negative 9, 0. Okay, so those two rows had them broken up again, right? This third row has the whole equation together, which is what we are going to see more often. So if we put those two things together, our vertex is going to be at h, k. So just by having those equations, we should be able to know the vertex. Okay, so again, we're just looking at the equation. So for this one, my h, remember, has to be the opposite. So instead of negative 3, I'm going to write positive 3. And my k value is just exactly how it appears. So this is positive 2. Here, again, it appears as positive 5. So my vertex is actually at negative 5, 8. Again, opposite sign, 7, negative 4. And negative 1, negative 2. Again, it's negative because it has to have the opposite sign. So again, you might just want to make yourself a note. I don't have a whole lot of room, but I can try to do it at the bottom here. So H has the opposite sign. Okay, and that's going to be important. Oops, it says psi. H has the opposite sign, and then K has the same sign. Okay, don't get confused by that. I don't mean same sign as H. I mean same sign as the equation. So I'll just say as equation. EQN's equation. Okay, so this is a summary on transformations of quadratic relations.